Hello students, welcome to tutoringcluster.com. So in this lecture, we are going to learn about some applications of trigonometry. So hope you have watched my previous two videos in which we have discussed basics of trigonometry and we have solved some very important examples. Now, let us begin with this class. Now, what are applications of trigonometry? Many a times we need to know the height of the tower or height of the building or height of tree or distance of a ship from lighthouse or width of river. Right? For example, let's say there is a building. I want to find its height, or let's say there is one tree, and let's say if you want to find its height, then what methodology you have to adopt? We cannot measure them actually, but we can find them with the help of trigonometric ratios. So these are applications of trigonometry. If you want to find the height of the tower, building, tree, or let's say if you want to find the distance of ship from lighthouse or width of river, then you can use trigonometry. So before start with actual examples, let us understand first what do you mean by line of vision. Now, if the observer is standing at location A, looking at an object B, then AB is called as line of vision. For example, let's say the observer is here. Okay, let's say this is a ground and observer is standing here. Okay, let's say there is one building. Let's say this is a building. Now, assume that this man or this observer is looking at the top of the building. Okay, now I'm drawing here one horizontal line. Okay, now which will be the line of vision? See, let's say this is the top of the building. So observer is looking with this direction. So this is called as line of vision. This is called as line of vision. Okay, now the second concept in this is related to angle of elevation. Now, if an observer at A observe the point at B, which is at a level higher than A, right? See, you can consider this as a ground. Okay, so assume this as a ground, right? So it is at certain height from the ground. It is at certain height from the ground. So in this case, AM, this is what your horizontal line, and angle BAM, it is called as angle of elevation. It is called as angle of elevation. Okay, so point B, it is at certain height from the ground. Okay, here is the observer. This will be your line of vision. Okay, so if you observe the direction, it is in which sense? It is in which direction? It is in anti-clockwise direction. It is in anti-clockwise direction. So angle which is measured in anti-clockwise direction, it is considered as angle of elevation. Okay, this B, it is elevated from the ground. It is at certain height from the ground. That's why it's an angle of elevation. So this is the first concept. Now the second angle is angle of depression. Now again, let us consider observer is at A. This is the, we can consider this as ground, let's say. Okay, or let's say in this case, observer is standing at the top of the building, at the top of the building, and is observing something on the ground. Okay, consider this as ground. Now let's say there is a bike here or a car here. Okay, now this point C, it is on the downside. Okay, it is on the lower level, it is on the lower level. Okay, so as observer is observing a bike or a car which is placed on the ground at point C, so this will be the line of vision. It will be a line of vision. So angle which is measured, this is which direction? This is clockwise direction. This is clockwise direction. Okay, if see, it's very easy. Where is the object? If it is at certain height from the ground, at the higher level, it will be the angle of elevation. Now let's say observer is at the top of the building and is observing something on the ground. So it is, object is at lower level from the observer. So that will be angle of depression. You can remember like this, or angle which is measured in anti-clockwise direction, angle of elevation, angle which is measured in clockwise direction, angle of depression. So these are the two concepts. Okay. Now, before starting the actual application, let us revise this thing. Now, these are the trigonometric ratios. We have total 6 trigonometric ratios, and these are the angles. So you have to remember this. Okay. Please try to remember this table. This is going to be useful for solving the examples. Now, angles are what? 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. So sine 0, it is what? 0. Then sine 30, it is 1 by 2. Sine 45, 1 by root 2. Sine 60, root 3 by 2. And sine 90 degree, it is 1. Now, you have to reverse this. Okay, bring this here. Bring this 0 here. Then root 3 by 2 you can bring here. Bring 1 by 2 here. And 1 by root 2 as it is. Okay, and what is sine of theta? What is tan of theta? Tan theta is nothing but sine theta upon cos of theta. So you can take the, you can divide this. Okay, you can divide this to find the tan angles. Okay, for example, let's say I am telling you how to find tan 30 degree. So tan 30 degree, it is nothing but what? Sine 60 divided by root 3 by 2. So 2 and 2, it will get cancelled out. It will be 1 by root 3. So this is what? 1 by root 3. Okay, please remember all these values. These are going to be useful. How you are going to find out cosec theta? Simply you have to take the reciprocal of sine. So take the reciprocal of 0, 1 upon 0. We cannot define 1 upon 0. So that's why not defined. Okay, 1 upon 2, what will be the reciprocal? 2. What will be reciprocal of 1 upon root 2? Root. Okay, what will be reciprocal of 1? 1. So please pause this video here, and you can also note down this complete table, and please revise and learn this table. Okay, now let us see now actual applications of trigonometry. So the first example, read the example. An observer at a distance of 10 meters from a tree looks at the top of the tree. The angle of elevation is 60 degree. What will be the height of a tree? Okay. So there is an observer which is standing at a distance of 10 meters from the tree. For example, suppose there is a tree here. Okay. This is your ground. Now let's say there is one observer here, right? The observer at a distance of 10 meter from a tree. So this distance is 10 meter. This observer is looking at the top of the tree. This observer is looking at the top of the tree. So this is your line of vision. The angle of elevation is 60 degree. What is this angle? This angle is 60 degree. What is the height of the tree? So they have asked you what is the height of the tree. Now I am going to draw a line diagram here. See, I am drawing one line. This is your tree. Okay, this is your ground. Now there is a observer here. He is looking at the top, making an angle of 60 degree. Okay, they have asked you what is the height of the tree, and this distance is given as 10 meter. So you can name this as, let's say this is triangle ABC. So AB, it represents what? Tree. Okay, then angle ACB, it is what? Angle of elevation. Angle of elevation. Okay, point A, it is at the top of the tree. And C is your observer. C is your observer. Right? So this will be a 90 degree. So what they have asked? They have asked you the AB. What will be the height of the tree? So how we are going to solve this? See, we are going to use a simple trigonometric ratio. If I have to write sine 60 degree, so what is sine 60 degree? What is the opposite side? AB. Now, hypotenuse. What is the hypotenuse? AC. So AC is unknown. What we know the BC. So what we have to take? You have to go with here tan, right? Okay, so tan 60 degree, opposite side upon adjacent side. So this is equal to what is AB? H. What is BC? 10. Now I have told you tan 60 degree. That's why I have asked you to remember that complete table. What is tan 60 degree? Root 3, which is equal to h upon 10. So what will be h? 10 into root 3. 10 into what is root 3? 1.73. So what will be the height of the tree? 17.3 meter. This will be your answer. Okay. So what is the methodology to solve this? Remember, the problem statement will be given to you like this. So try to visualize, try to make the diagram out of it. After that, you can draw the line diagram. Once your diagram is made, the rest part is going to be very easy. Okay, simply you have to use rules of trigonometry. Okay, I hope this example is clear. So let us see the next example. Now, from the top of the building, the observer is looking at a scooter which is parked at some distance away. Makes an angle of depression of 30 degree. Okay. Now, what is the situation here? See, there is a building. Consider this as a building. This is your ground. This is the building. This is the top of the building, obviously. This is your ground. Okay, now read. From the top of the building, observer is looking at a scooter parked at distance away. So there is one scooter here. This is your scooter, which is parked somewhere on the ground. And observer is looking at the scooter. Observer is looking at the scooter. So this is your line of vision. Where is the observer? This is your observer. Okay, making an angle of depression. So this angle, how much it is? 30 degree. Okay, how we measure the angle of depression? If this is your horizontal line, so angle which is measured in anti-clockwise direction. So if I am drawing one line here, so this angle, it is going to be 30 degree and not this. Okay, remember the definition. So this angle of depression is how much? 30 degree. Okay, now if the height of the building, what is the height of the building? 40 meter. So this is 40 meter. How far the scooter is from the building? So they have asked you this distance. Okay, so if I have to draw the line diagram here, how the line diagram is going to look? See, so there is a building. Okay, then this is your ground. So this angle, how much it is? 30 degree. This is the top of the building. Here it is a scooter. Here it is a building. So again, this you can consider it as ABC triangle. Now this angle, these are what? Alternate angles. This will be 30 degree. Now what is the height? Height is 40. So AB, it is what? 40 meter. So you have to find out BC. So which trigonometric ratio you are going to use? If you write tan 30 degree, see here, tan 30 degree. What is tan? Opposite side upon adjacent side. What is AB? 40. BC is unknown. So what will be BC? 40 divided by tan 30 degree. 40 divided by, what is tan 30? 1 upon root 3. So 40 root 3. So root 3 it is given 40 into 1.73. So BC, it is equal to 40 into 1.73. 69.2. 69.2. What will be the unit? Meter. Why meter? Because 40 meter it is given. So this will be your answer. So scooter is far from the building and it is at a distance of 69.2 meter. Okay, so in the first example, we are talking about angle of elevation. In this example, we are talking about angle of depression. Okay. Now, the question is why I have not taken this angle as 30 degree. See, angle of depression or angle of elevation, these are taken with respect to horizontal line. Okay, so if I am taking this as 30 degree, it is with vertical, which is not correct. You have to always take angle with horizontal line. So this is your horizontal line. Okay, right. Let us see the next example. Okay. To find the width of the river, the man observes the top of the tower on opposite bank, making an angle of elevation of 61 degrees. Okay. So there is a width. To find the width of the river, the bank observes the top of the tower on opposite bank. So consider there is a building here. Okay, let me change the color. There is a building here. Okay, and there is a river here. Okay, This is the river. This is the building. Now, the man observes the top of the tower on the opposite bank, making an angle of elevation of 61 degrees. So, man is standing here. Man is standing here. Angle of elevation, how much it is? 61 degrees. Okay, now read the next. When he moves 50 meter backward from the bank, so he's moving like this. So this is your 50 meter. Now observer is here. So from this position, what is the angle of elevation? 35 degree. So now when he is observing this angle is how much? 35 degree. Find the height of the tower and width of the river. So this distance. Okay, I hope this diagram is clear. Let us try to make the line diagram out of it. So see here, there is a building. Okay, and so at the first, consider observer is here. This is the top of the building. So this angle it is how much? 61 degree. Now when he moves 50 meter backward, this is your 50 meter. Then what is the angle of elevation? Angle of elevation is 35 degree. These are the given thing. Now what you have to find out? You can name this as, okay, let's do the naming. This is A, B, C and D. You have to find out AB. AB is equal to what? And you have to find out BC. BC is the river. Okay, so if I have to name, this is your river and this is your building. Right? Now, how you are going to find this? Okay. Let height of the building, let's say it is X, and the width of the river, it is what? Y. Okay. Now, if I have to write tan 61 degree, see, K you can get it from here also. The tan values are given, so you have to go with tan ratio. Tan 61 degree, which is equal to, what is tan 60? Tan means what? Opposite side. What is opposite side? AB, which is nothing but X, divided by adjacent side BC, which is nothing but Y. So what is tan 61? 1.8, which is equal to X upon Y. This is your first equation. Okay, very easy. Next, tan 35 degree. Tan 35 degree. What is the opposite side? See here. This is your 35 degree. Opposite side is what? X divided by adjacent side. So this distance will be what? Y plus 50. Is it clear? Okay. So tan 35 degree X upon Y plus 50. What is tan 35? 0.7, which is equal to X upon Y plus 50. Basically, you have to find out X and Y. So these are the two equations and there are two unknowns. Let us see how to solve this. So from the first equation, what will be X? 1.8 times Y. Okay. Now, what will be X from this? From the second equation, 0.7 in bracket Y plus 50. So what you are going to get? 1.8Y, which is equal to 0.7 in bracket Y plus 50. So 1.8Y, which is equal to 0.7Y plus what is 0.7 into 15? 35. Okay, so therefore, if I am taking this zero point 0.7 here, so 1.8 minus 0.7 y, which is equal to 35. So what is 1.8 minus 0.7? 1.1. 1.1 y, which is equal to 35. So what will be y? 35 divided by 1.1, which is nothing but 31.8. So what is the width of the river? 31.8 meter. What will be x? What will be x? 1.8 times y. 1.8 into 31.8. So into 1.8. So it will be 57. 57.2 meter. Okay. So what are your answers? The width of the river. How much it is? Approximately 31.8 meter. And what is the height of the tower? 57.2 meter. These are your answers. Okay, so this is how you have to approach the given examples. Okay, see, the wording and the example will be easy. Just try to visualize the building, then river, where man is standing, then how it is moving backward, what are angle of elevations, then angle of depression. See, 61 degree. Again, it is an angle with respect to horizontal. Okay. So this is how we have to solve. Now, let us see the next example. Okay, a very good example. It is a little bit lengthy, but let us check this out. The Roshni saw an eagle on the top of the tree at an angle of elevation of 61 degree. Okay. So Roshni is standing here. She is observing an eagle at the top of the tree. This complete is your tree. It's a huge tree. This is the top of the tree. Here it is the eagle. So while observing this, what is the angle of elevation? 61 degree. Now, while she was standing at the door of her house. So this is the house, you can say, or this is a ground. Now, she went on the terrace. So she went on the terrace. Now, this is the new position of Roshni. And now she could see the eagle clearly. Okay, again she is observing the eagle. Position of eagle is not changed. Only the position of Roshni is changed. First she was at the ground and now she has moved on the terrace. The height of the terrace at a height of what? 4 meter. While observing an eagle from there, the angle of elevation, it is how much? 52 degree. At what height from the ground was the eagle? So basically, you have to find the height of the tree. Okay, what they have asked, at what height from the ground the eagle was. Okay, so you are going to try this example. How? See. So, if the height of the building is 4, first you can draw one perpendicular line here like this. Okay, you are drawing one perpendicular line. So this will be 4. Okay, let us assume this distance as x. Okay, and this distance as y meter. Okay, so this is going to be what? Rectangle. This is going to be what? Rectangle. So obviously this is going to be x. This is going to be what? X. Now, if I am considering this triangle, observe it carefully. If I am considering a triangle, this, just a minute. Okay. If I am considering this triangle, RSP, RSP. This angle is 61 degree. This angle is 90 degree. So what will be this angle? 29. Okay. Second triangle you have to consider as RTQ. This angle is 52 degree. This angle it is 90 degree. What will be this angle? 38 degree. Okay, sum of all the angles of triangle is how much? 180 degree. So 52 plus 90 plus x is equal to 180. So you can find the x. So it is going to be 38 degree. Okay, now how you are going to solve this? If I am taking tan 61 degree, okay, let us solve this. See, if I am taking tan 61 degree, tan 61 degree. So opposite side 4 plus y divided by x. Okay, tan 61 will be given to you. Okay. What will be tan 52 degree? Y divided by x. So there are two equations. Equation 1, equation 2. And there are two unknowns. What are the unknowns? X and y. So two equation, two unknowns. You can easily get x and y. Okay. So you please try this in case if you are not able to solve. Okay. Ask me. See, tan 61 it is given to you. Okay. So things are given to you. Then tan 52 that is also given. Tan 52 that is also given. So there are two equations, two unknowns. You can get height of the tree easily. Right? Now let us see the next question. The last one. Now the tree was broken due to storm. Its broken upper part was so inclined that its top touched the ground, making an angle of 30 degree with the ground. Okay, so there is a tree. So due to storm, this was broken and it has rested like this. This is your ground. Okay. The distance from the foot of the tree and the point where the top touched the ground was 10 meter. So this tree, its upper part, it was broken and it has rested on the ground. So this is the upper end of the tree. This distance, how much it is? 10 meter. Okay, the distance from the foot of the tree. This is the foot and the point where top touched the ground. So this is the point at which the top is touching. So this is 10 meter. And this angle is how much? 30 degree. Okay. Right. So if I have to draw the line diagram, how it is going to look like? So this is the tree. Now this is your ground. What is happening? See here, due to this storm, the tree, its upper part, it got broken and it is resting like this. So obviously this and this part are going to be equal. Okay, these are the same part only. This is your complete tree. Due to storm, let's say it has cut here and it is resting on the ground, making an angle of 30 degree. And what is this distance? This distance is 10 meter. So you can consider this as ABC. This is your 90 degree. So let's say this is X, this is Y. Okay, we can assume like this. So if this is Y, obviously this distance is going to be Y. You can consider this as point D. Now, if you are considering triangle ABC, what will be tan 30 degree? Opposite side upon adjacent side. So what will be X from this? 10 into tan 30 degree. So 10 into what is tan 30? 1 upon root 3. Now, in the same triangle, if I have to write cos 30 degree, adjacent side upon, this is the adjacent side upon hypotenuse, that is Y. So therefore, what will be the Y? Y will be 10 upon cos of 30 degree. So 10, what is cos 30 degree? Root 3 by 2, which is equal to 20 upon root 3. So this is Y. So what is the height of the tree? Height of the tree, which is equal to X plus Y, which is equal to 10 root 3 plus 20 root 3, which is equal to 30 root 3. Okay, so height of the tree is what? 30 upon root 3 meter. Right, so this is the simple methodology to solve the given example. So they have asked you what is the height of the tree. So it is what? X plus Y. So this is a right angle triangle. Okay, so this distance is what? 10 meter. So we have used first tan 30 degree. What is tan 30 degree? Opposite side X upon adjacent side X upon 10. So find out X from this. Next, cos of 30. What is the cos? Adjacent side upon hypotenuse side. So 10 upon 1. So what will be Y from this? Y it is equal to 10 upon cos 30. What is cos 30? Root 3 by 2. So take this 2 on upside. So it will be 20 by root 3. So height of the tree it will be X plus Y. So it will be 30 upon root 3. Okay. So these are some examples based on applications of trigonometry. So in the next video, we are going to solve the exercise 6.2. Thank you.